Ladies and gentlemen, it is now my privilege to introduce the esteemed second keynote speaker of the day, Dr. Somesh Kumar. Dr. Somesh Kumar is an assistant professor in the Department of Electrical and Electronics Engineering at Atal Bihari Vajpayee Indian Institute of Information Technology and Management. An accomplished researcher and academician, Dr. Kumar's area of research encompass VLSI design, 3D ICs and TSVs, high-speed interconnects, antenna system for emerging 5G and 6G technologies, nanoscale device modeling, and machine learning applications in electronic design automation. He has contributed extensively to several government-funded research initiatives, has published numerous scholarly papers in reputed IEEE SCI Index Journal. In addition, he actively serves the academic community as researcher, reviewer, mentor, and senior member of IEEE. His scholarly contribution and dedication towards cutting-edge technological research continue to inspire innovation and academic excellence in the field of electronics and communication engineering. It is our immense honor and privilege to invite Dr. Somesh Kumar to deliver his keynote address. Sir, please.
So, good noon to everyone. Maybe good noon or good afternoon, right? It's more than 12 o'clock, yes. Yes, good afternoon, everyone. Yeah. Okay, so thank you, Professor Christian, for giving this wonderful talk about, fintech and the financials, scenario in the Philippines. And I want to say the same scenario in our India, like from COVID-19, the digital transactions, drastically increased in our India also. So thank you very much for providing this insight about in your talk about the Philippines. So, and also welcome you in India. On behalf of IEEE MP section and on behalf of the Professor G.S. Tomar and on behalf of, because I am the Joint Secretary in IEEE Madhya Pradesh section, so I welcome you in Madhya Pradesh. So today my talk is on more technical side, right? But I will try to make it more interactive and I will try to connect you like future of the technology. So today my talk is on the flexible interconnects for heterogeneous integration on flexible substrates. So I will not go into the very detail of this topic. So I will just give the overview, what is the flexible devices, what is green electronics sometimes we are saying, right? And what is the meaning of or the role of the flexible interconnect in that, right? And what will be the future of this technology, where you people can work on this technology, and at the current position, where is this technology stands, right? So from the audience, can anyone tell me what is the meaning of flexible devices, or can you give any example of the flexible devices? Yes. Okay, so just I will give the brief idea. So flexible electronics, also called the green electronics, right? So nowadays, maybe all of you, some of you have heard about the electronics skin. What does it mean? So nowadays, the main difference between any robot or the human beings is the emotions, right? I'm right. So we are saying that robots did not have the emotions while the human beings have the emotions, right? So with the help of this flexible electronics, this is just one example I want to say. So with the help of this flexible electronics, researchers are trying to fill this gap. So actually they are working on a skin. That skin is, we are pronouncing it as electronic skin. That skin can be placed on the robots, and then robots start sense, right? Sense with the help of, yes, of course, with the help of these electronic devices like various sensors, right? So that electronic skins contains various sensors, and so that these robots can automatically take the decisions. For example, if there is some fire, and the robot can sense that and can protect themselves, right? So these kind of decisions that is taken by the human beings, that can be taken by the robots with the help of the electronic skins, right? So this topic is related to this kind of applications, right? So as per that time, we will not go into all these topics, but some of these topics like what is flexible electronics and why the flexible interconnects, and then we'll discuss some about the materials for the flexible interconnect, and then the various type of flexible circuits we will discuss with some examples, right? And yes. So this is just one example of, here it the word one word is written, that the flexible hybrid electronics, right? What does it mean, flexible hybrid electronics? Flexible hybrid electronics, because to make a system completely flexible is a very challenging task, right? So that's why some components like some interconnects or some basically ICs we are make the flexible on some rigid substrate. So means the combination of flexible and the rigid things makes the hybrid electronics, right? As you can see in this basically integrated circuit or on this PCB, right? This PCB is flexible in nature, or this is the substrate, and this substrate mainly in layman terms we can say made up of the plastics, right? So on this, as you can see, right, this is this 3D ICs, this is rigid one, and some these batteries, some these solar cells, these some sensors, PS sensors, generators, and these are basically these gray ones are nothing the interconnects, right? Interconnects are nothing, just the wires on an IC or on an device that are used to connect the between die or the connected, right? So these are the flexible in nature, while these 3D ICs are basically rigid in nature. So this is the combination of flexible as well as the hybrid systems, right? So from Peter MacLeod is very renowned scientist from flexible circuit technology. He gave this statement that flexible circuits are a high growth technology in the area of electrical interconnectivity and look set to deliver the improved performance against the demand of many 21st century products. Flexible printed circuits have replaced hand-built wire harness in many applications, right? So this we already discussed about the flexible hybrid electronics, and the flexible electronics generally refers to a class of electronics devices that is built on the flexible or the stretchable substrate, right? So means in the flexible electronics, all your substrate on which it is grown, right? For example, any sensor or any chip which is grown on a substrate, right? Generally we are using the silicon substrate, right? All the silicon substrate. So for the flexible electronics, the first main thing is the substrate also the flexible in nature, as well as the layer, like for example the passivation layer or the adhesive layer, and then on the top of it that is the interconnects. All these layers also should be the flexible in nature, right? And all these layers should match the same Young modulus. We are saying Young modulus is one performance matrix, ratio of stress upon strain to measure the stretchable property, right, of all the layers. So these should be equal, otherwise what will happen if substrate is not flexible but the upper on that the other layers are stretchable, then there is no use, because ultimately the whole system should be flexible in nature, right? So one common example that you people are like using in your daily life, that is the Samsung Galaxy Fold, right? This is one mobile phones. In that, what is there? This kind of technology is inbuilt in that. But after this Samsung Fold, why there is a no such more kind of handsets or from various different companies not into the market? Because this technology have some challenges also, right? So due to this reason, because Samsung Fold is from last 4 to 5 years it is in the market, but no other phone like this is into the market, right? So that's why. So this flexible electronics is also called the printed electronics. Why it is called the printed electronics? Because the fabrication of these flexible devices is not not done by the conventional methods like photolithography and all, right? So for the fabrication of these we use the printed circuit technology, right? Directly we are printing, like in your printers, like directly you are taking the printout of anything, like similar in that manner with some conductive ink and all. This printing is directly done with this printing circuit technology. So that's why it is also called the printed electronics, right? So these some techniques like screen, inkjet, flexography and others, right? So this is just one example of the flexible circuits on the sheet. So in this circuit or in this plastic sheet, hundreds of circuits are seen. In the semiconductor technology or in the semiconductor area, it is not worth to grow a single circuit on any substrate due to the cost limitations, because to fabricate a single device is very costly. So that's why at the same time we are making a number of all these similar circuits on the substrate, because the process method is same. So that's why a number of circuits we are grown on a substrate like this it is shown. And then this is just one images of flexible battery, right? Because for flexible system the battery also we need the flexible in nature, right? So this is your one example. Yes, this is also one example of flexible hybrid electronics. This is example of your transparent substrate, right? And the transparent substrate, as you can see, this circuit is printed on the top of this transparent substrate, and the substrate can be folded like this. Okay, so one more example of this technology is the foldable keyboard. Maybe some of you have the keyboards, right? The keyboards can be folded, can be put into the bag. What is the benefit? In layman terms, what is the benefit of this technology? Yes, space, right? So in layman terms, like the keyboards can be put into in less space rather than the rigid keyboard, right? Similar to that, if your device is flexible, then within that system, right, we are talking about whole system, right? Within that system we can put that device at within the less area, right? And nowadays when if you are talking about like in the semiconductor mission that all of is launched in India by our Prime Minister. So in that basically the whole this technology depends on the size, or we are saying this in technical terms, the technology node, right? So nowadays these Intels, they are using less than 3 nanometers, even 1 nanometers, and after that if limit is reached, now we are talking about the quantum technologies, right? Because quantum size, we reached the quantum size, right? So this is about this. So these are some applications that we already talked, like in the displays, photovoltaics, digital X-ray imagers, and automotive industry. So here we can use this flexible technology, right? So these are some applications. Yes, this is the roadmap of flexible technology and the product. So we divided this into the phase 5, starts from 2000 to 2010. This is the first phase. In that phase basically the key product in that phase is the flexible displays, not completely flexible, but some curved kind of displays comes into that picture. In that RFID tags, right? This is also just one great example of your flexible electronics that was used previously, also used nowadays in your hotel rooms and all, and in your ATM cards and all this is there. So flexible keyboards, e-paper, right? And in the second phase, like your smartwatches, right? Inside your smartwatch there are a lot of sensors, right, that can sense directly data from your body, right? This is the also example of your stretchable electronics. That is the phase 2. In the phase 3, from 2020 to 2026, right? So in that, basically that hybrid integration of these and the advanced packaging, ultra thin batteries, and the flexible antennas also, and the electronic skin that I talked about, that is currently going on in this phase. And then in the future, fully stretchable electronics like smart band, like that band, or smart we can say stickers will be available in the future. Those stickers can be directly put on your screen, because that sticker, because the electronics within that stickers should be flexible, right? Because your hand or your skin is flexible in nature. So only that's all the components that will be placed on that will be flexible, so that it will not affect your daily life activities, right? So that's why with that sticker, what will be the possibilities? All your body data can be transferred into your database or any system, and for the record, and then later on you can analyze all those data, right? And then in the long terms, basically like smart contact lens, brain machine interfaces, foldable tablets, laptops, right? Fully wearable medical systems, right? Will comes into the future. So this is why I already talked. Now this is some interconnects. I told you interconnects are basically your wires, like simply these wires. These are called wires, but in terms of ICs we are saying it the interconnects, right? These are used to connect the various devices. And if you especially talk about the flexible, then these are some categories of these: flexible printed circuits, stretchable interconnects, printed conductive trace, serpentine interconnects, and the textile based conductive paths. Means the interconnect that is made on textiles like your cloths and all. Okay, so like already told, all these layers will be flexible in nature, right? I already told you that because in the mainly 4 layers that are used. One is flexible substrate, then the adhesive layers, then the conductive layers, and the protective layers. Protective layers basically protect any device from the outer environment, like from the humidity and all, so that its reliability can be increased, right? I will not go into this. Lot of things I will skip because of the time limitations. So these are some basically materials that can be used for the flexible electronics. The main use nowadays is the graphene, right? So what is the difference between graphite and the graphene? Graphite is like your pencil nib, right? That is graphite. If we take a single layer of that becomes the graphene, right? Graphite is non-conductor, graphene is conductor in nature, right? Like in nanometer, 0.13 nanometer, that much of thickness from that your graphite we take, that becomes the graphene, which is flexible in nature, right? And for any substrate, like for the copper wire, like if we reduce its thickness, it becomes the flexible. But why we can't use the copper in the flexible technology? Because if you reduce the thickness, there is a chance so that it can break down, right? Some defects and it can break down. So that's why these limitations. These are some conductive materials, and these are some substrate materials. I told you that the top materials like the conductors also flexible and the substrate also flexible. So these are some examples of the plastics. These are our plastic class like polyamide, polyethylene terephthalate, polyethylene naphthalate, and PDMS, TPU. All these have some advantages and limitations. If you are interested, I will share these slides with you if you want to work on this technology. And these are some interconnect architectures that I told you, that this is the top view for the rigid structures, and for the flexible it will look like that, right? The main thing is, or the main research is, if we make any device flexible, so its electrical property or thermal property, right, will remains same, right? Means if you bend any structure, right, its conductivity will not change. This is only the research, right? So that its performance will remain same, right? Otherwise, if you bend it, then if its performance will degrade, then its reliability can be decreased, right? So this is like the measurement, like these are the some terms, I'm not going to the detail, which can measure its bendability or the flexibility, like Young modulus. If you are from technical background, then maybe Young modulus is the ratio of the stress and the strain. So this is like how much length will be increased and divide by the original length. This is the strain, and in the stress here, this is the stress, and in the strain basically we are measure about the area, how much if you apply, you can care that what are the materials we are using inside that will not affect our body, right? Okay, so yeah.
Sir, I just want to know that the devices which are technically refined day by day,
Mm-hmm.
so they are decomposable or not? They remain on the earth for a very long time, right? We are saying that the silicon is disrupting our earth. So that's why I'm asking.
Yes, we can say this is basically electronics waste, right? Electronic waste cannot be, as per my knowledge, it cannot be completely degraded. It can be reusable, right? So rather than completely destroying it, people are trying to reuse it, right? From the electronic waste, we are generating, like people are trying to generate this graphene, these different kind of energies, like this kind of work we are doing, right? Because this can't be completely decomposed like this. Okay. Yes. Okay, so I will share my slides to the organizers. You can take from them, right? And otherwise, if you want to contact me, my email ID is there, somesh@IIITM.ac.in, and I'm available on, when you search Somesh Kumar IIITM Gwalior, you will find on the Facebook or on the LinkedIn, or you can connect me, right? So with this note, thank you very much for giving that time to me. Okay, thank you very much.
Conclusion of this inaugural and keynote session, it is now time to formally acknowledge and express a heartfelt gratitude to all those who contributed toward the grand success of this prestigious international conference. May I now respectfully invite Professor Nishant Singh Kushwaha, co-convener of the conference ICADCS 2026, to deliver the vote of thanks. Please, sir.
Thank you, Som. Honorable Chief Guest, esteemed keynote, other dignitaries and academicians, participants. On the behalf of Vikrant University, I would like to extend my heartfelt gratitude to our esteemed keynote speakers, Associate Professor Christian Inoval and Dr. Somesh Kumar, Assistant Professor, Department of Electrical and Electronics Engineering, Atal Bihari Vajpayee, IIITM Gwalior. It's really impressive how Professor Christian started his session with the short introduction of his country, the daily life struggles of the people against the natural calamities like earthquake and typhoons, and a sharp drift which has taken by both the countries, India and Philippines, during the COVID, from cash to cashless transactions. I am also grateful to Dr. Somesh Kumar. He delivered his session more on the technical sides, It's really a new word, especially for me. I really heard it's my first time to hear green skin or electronic skin. We deeply appreciate their gracious presence, valuable time and contribution towards strengthening the spirit of innovation, research and interdisciplinary collaboration. I would like to thank all the dignitaries, delegates, faculty members, industry experts, participants for their enthusiastic presence. I would like to thank each and every members directly or indirectly involved in this conference. Thank you very much.